What's up everyone, Patrick here, welcome back. Moving on to the next question. So we are told that the points A, 10 and 4, B, -2 and 0, and then C, 2 and -2 lie on a circle. And what we have to do is we have to find the equation of the circle. So notice in this case, we're just given the points that lie on the circle, or we're not given the center. We're actually going to have to figure that out. So just as a recap, if we have a circle that has a center at H and K, well, we know that the formula for that circle is going to be x minus h squared plus y minus k squared is equal to the radius squared. So ultimately, our answer is going to be in this format, but we're going to have to do quite a bit of work to get here. What we're going to have to do is we're first going to have to find the center. How can we do that? Well, what we can do is, because we are given 3 points on a circle, so let's label this. So we got 10 and 4, A, we'll have B, which will be at -2 and then 0, and then let's label C over here. Now these points are not necessarily to scale. If you were to draw them on a Cartesian plane, they're probably going to look different, right? But I'm just drawing a rough diagram so we can have a reference with what we're going to be doing algebraically. So we only have the points. Notice that we need the center and we also need the radius, right? But once we have the center, then we can figure out what the radius is, because the radius is just going to be the distance from the center to any point on the circle. So really, once we get the center, then we're all good. We can get the equation. The question is, how do we get that center right there? Well, if you remember, the right bisector of any chord always goes through the center. So what we can do is we can find two chords. So let's say maybe we find the chord AB, and then we can find either the chord BC or AC. I'll probably just work with AC, but you could also find the chord BC. We only need 2 of them because we only need 2 right bisectors of those chords. So there's going to be the right bisector of chord AB, and then we'll have the right bisector here of chord AC. And remember, those right bisectors are always going through the center. So once we have those 2 equations, we can find where they're going to intersect, and they're going to intersect at the center. So that's how we could get this center over here. And then once we have the center, we can just plug in one of the points to get the radius. All right, now again, you can also find, if you want, the chord BC and then find the right bisector of BC. It's also going to go through that center. But again, you only need 2 right bisectors of 2 chords to find that point of intersection right there. There's also another property that I want to quickly mention over here, is that this only works, okay, these 3 points, it's only going to work if the points are non-collinear. So 3, the property is only one circle passes through 3 non-collinear points. Right? So these points here, they can't be collinear, meaning that you can't have 3 points that are on the same line like that. Okay, then these 3 points aren't going to lie in a circle, right? And you're going to be able to figure that out. You don't necessarily have to check whether they are collinear, right? You can, if you want, you'd find the equation of this line, for example, and then make sure that this point isn't on this line, or find the equation of this chord and then make sure that this point isn't on that same line. But you'll know that they're not collinear if you get a point of intersection here, because if they were collinear, then if we got the right bisector between these 2 points and then got the right bisector between these 2 points, let's say, Well, notice that those right bisectors, they're actually never going to intersect. They're just going to be parallel. So you would get no solution when you solve for that point of intersection. So you'll know later on in the work whether these points are collinear or non-collinear, and if a question does give you 3 points on a circle, it just means it's implied that they're not collinear. But just wanted to state that in case maybe like a communication question comes up, or maybe your teacher mentions it, right? These 3 points that are given on a circle, they have to be non-collinear in order for one circle to go through them. Okay, so just wanted to mention that. So what we can do is, at this point, let's find these 2 right bisectors, right? So the right bisector of the chord AC and then the right bisector of the chord AB. So let's first start off with the right bisector of the chord AB. So what are the steps here? Well, first we got to find this midpoint of AB. So the midpoint of AB, remember, what is the formula? It's x1 plus x2 divided by 2, y1 plus y2 divided by 2. So we would add up the x values, 10 plus negative 2 divided by 2, and then add up the y values, so 4 plus 0. That'll be divided by 2. 10 plus negative 2 is like 10 minus 2, which would give us 8, 4. So we'd end up with 4 and 2. Like that, right? So that's this midpoint over here. That's going to be 4 and 2. Now what we can do is we could find the slope of the chord AB. So we're going to find the slope of this line, and then once we have that slope, we can get the negative reciprocal to find this slope of the right bisector, right? The perpendicular slope. So the slope of AB, y2 minus y1 over x2 minus x1. So let's label this. Let's label this x2, y2. Let's label this x1, y1. Technically, you could also use the midpoint if you want, because it's part of that same line. But I'm just going to use the endpoints. So we would have y2, which is 4, right, minus y1, which is 0, over x2, which is 10, minus x1, which is negative 2. So this would be 4 over 10 minus negative 2 is like 10 plus 2, 12. This would be 1 over 3. So 1 over 3 ends up being the slope of the chord AB. So now that we have AB, what we want is the perpendicular slope, so we would get the negative reciprocal of that. So we would flip that and change the sign. So positive to a negative, 3 over 1, so we end up with negative 3. Right, that's going to be the slope of this right bisector over here. So we have the slope of that right bisector, negative 3, and we have a point that is going through 4 and 2, so we could find an equation, y equals negative 3x plus b. Plug in 2 for y, we plug in 4 for x, negative 12 plus b, to bring the negative 12 over, 14. Right, so the b value is 14. So the right bisector of AB has an equation, y equals negative 3x plus 14. So let's actually write that over here. We got enough room, negative 3x plus 14. That's this right bisector right there. That's the equation of it. So now we got to find the right bisector, the equation of the right bisector AC. So we're going to find this right bisector. Now again, you can use BC. You can use the chord BC if you want as well. If you want to find all 3 and then just verify that they're going to intersect through that center, you can do that as well, just for further practice, maybe for algebra. In this particular video, I'm only going to find the 2 right bisectors of AB and then the chord AC, which I'm about to do. So first we would find the midpoint of AC, so that's this point over here. So we would add the x values, 2 plus 10 divided by 2, and then add the y values, negative 2 plus 4 divided by 2. So we'd end up with 12 over 2 and then 2 over 2, which would give us 6 and 1. So this midpoint here has a coordinate 6 and 1. Then what we want to do is we want to find the slope of AC and then get the perpendicular slope. So the slope of AC would be y2 minus y1 over x2 minus x1. Notice A we already have labeled as x2, y2, so C I'll label as x1, y1. So we'd have y2, which is 4, minus y1, which is negative 2. Be careful with the brackets there because it's a negative. x2 minus x1, right? Yeah. So this would end up being 4 minus negative 2 is like 4 plus 2, 6 over 10 minus 2 is 8. This simplifies to 3 over 4 if we divide the numerator and denominator by 2. So this slope of AC is 3 over 4. What's the negative reciprocal of that? Negative 4 over 3. Flip it, change the sign from a positive to a negative. So this right bisector over here, it has a slope of negative 4 over 3, and it's going through the points 6 and 1. So what we can do now is we can find out what the equation is going to be, negative 4 over 3x plus b, like that. So this would be, we'd plug in 1 for y, and then plug in 6 for x, and then we can solve for that b value. So we would have 3 goes into 6 twice, negative 4 times 2 gives us negative 8, right? Or negative 4 over 3 times 6 is negative 8, plus b, bring the negative 8 over, 1 plus 8 would give us 9. So this right bisector over here has an equation y equals negative 4 over 3x plus 9. So we have the equations of the two right bisectors, this and then that. And now what we could do is we could find the point of intersection between them using either substitution or elimination, and then that point of intersection is going to be the center of the circle. So let's write out, let's do it over here actually. Keep this general equation written out. So we got y equals negative 4 over 3x plus 9. We got y equals negative 3x plus 14, like that. So different ways you can find the point of intersection. Whichever way you're going to do it, you may have a particular method you want to do, whether elimination, substitution. So whichever way you're doing it, just make sure you're getting that same point of intersection. What I'm going to do is I'm actually just going to make these equal because the y's are already isolated. So we'll have y equals negative 4 over 3x plus 9. So it's like we're plugging this into this y. And then that's going to equal negative 3x plus 14, like that. And then from here, notice we're dealing with a fraction here. So what I'm actually going to do, I'm going to get rid of that fraction. So I'll multiply everything by 3. You don't necessarily have to do that. You could work with fractions if you want. So bring all the x's to one side, bring all the numbers to the other, and then divide accordingly. But before doing that, I'm just going to multiply everything by 3 because notice then the 3's here would cancel out. So we'd end up with a negative 4x plus 27 equals negative 9x plus, that would be what, 42? Like that. And now notice we're not dealing with any fractions. I'll bring the negative 9x over. That would become positive 9x. And then I'll bring the 27 over, so we'll have 42 minus 27. This would be 5x. And then 42 minus 27 would give us 15. Then to get this x by itself, we divide both sides by 5. 15 divided by 5 would give us an x value of 3. Right? So that is the x value of the point of the intersection. Right? So this here, it's going to, this point here, it's going to have an x value of 3. Then if we want to get the corresponding y value, we could just take that x value of 3, plug it into either one. Notice that whichever one we plug it into, whether it's this one, notice the 3's would cancel out, we get a y value of 5, or if we plug it into this one, we'd end up with negative 9 plus 14, which would be 5 as well. So whichever one you plug it in, we get that corresponding y value of 5. So 3 and 5 is the center of the circle, right? That's the point of intersection of the right bisectors of the chords. If you also get the right bisector of the chord BC, it should be going through that point, 3 and 5. Okay, so that's the H and the K. Right, so now we got the center. What we can do, plug in here. Right, the H is 3, and then the K is 5. So we'd have x minus 3 squared plus y minus 5 squared is equal to r squared, like that. Now from here, we need the radius, right? So a couple of ways to get the radius. We've gone through this in previous videos. You could find the distance from here to here, or sorry, that's this point, my bad. Sorry, there's a lot going on here. From here to here, or here to here, or here to here, basically the distance from the center to any of the points on the circle. But another thing you could do is you could just take any of these points that are on the circle. Okay, let me just erase this. Right, so we could take the A, the B, or the C, and we could plug it in here and get an expression for r squared that we could just plug in there. It doesn't matter whether you plug in 2, -2, 10 and 4, -2 and 0 for the x and y, you should get that same value for the radius. So what I'm going to do is I'm actually going to plug in, again, it doesn't matter, I'll plug in the -2 and 0, so we'll have -2 minus 3 squared plus 0 minus 5 squared equals r squared. So we would have -5 squared plus 0 minus 5 is -5 squared. So we would have what? 25 plus 25, and then that would be 50. So the r squared is 50, right? And then we could just take that 50 and actually just plug it in here. We don't have to find the radius and then square it again, right? We could just take that 50 and then put it right there. Okay, but if they do ask for the radius, it's the square root of 50, right? That's going to be the distance from the center to this point, or to that point. Okay, and if you want to simplify this, root 25, root 2, 5 root 2 in case your teacher wants you to simplify radicals. They may not. So if you haven't gone over that in class, don't even worry about that step. Radius is just root 50. If you want to get the decimal, it's going to be 7 point something. And then, yeah, that's it. That's the equation of the circle right there. And if you want to test it with maybe another point just to be really sure, or maybe with all 3 points if you have time on a test. So notice what would happen if we plug in the point 10 and 4. So we'd have 10 for x, then we would plug in 4 for y. Notice we would have 7 to the power 2 plus -1 to the power of 2. What do we get? 49 plus 1. We get that same value of 50 for r squared that we plug in right there. Okay, if you plug in 2, -2, you'd get 50 is equal to r squared as well. So if you do have time, you can plug in the other points just to be really confident that you are getting the same value for that r squared for that radius, no matter which point you plug in. Right? But either way, that right there, that ends up being the final equation of this circle. So if you get a question like this where they only give you points on the circle, 3 non-collinear points, you got to find the equations of 2 right bisectors of 2 respective chords, find where they intersect. That's going to give you the center, and then once you have the center, finding that radius is pretty simple.